morning, and thank you for joining us on our next talk. We're here today with Erfan Vafaie, our Extension Program Specialist for IPM from Overton. So we're so happy to have him join us today because this is actually a viewer request. So we had someone email us and tell us they wanted to know more about pollinators and pesticides, what we can do to help the declining bee population in our own backyard.
Thank you so much, Rusty. I'm glad you all got my request, and I'm glad that I'm here for it.
So a note to other speakers, if you want to be a presenter, the way to do that is to email next@ag.tamu.edu, and we'll get you on here.
Absolutely. Thank you so much. And I want to first start off by saying that, a lot of people are very concerned about the honeybee, and there's a good reason for that concern. But there are a lot of other pollinators out there as well. So for example, we have a number of different species of moths and butterflies as well that are pollinators. We have different types of wasps. This one here is known as the cuckoo wasp. What it does is it looks for a cockroach, it will sting it and paralyze it, lay an egg on it, and that egg will hatch and a larva will eat it alive, which is such a pleasant sight for those of you who have been trying to kill those cockroaches with your shoe. We also have, here's the monarch butterfly. As we know, a lot of people, monarch butterfly populations have also been experiencing a lot of declines as well. And this is a chrysalis of a monarch butterfly going from caterpillar to a new butterfly.
Perfect.
And here we have it now, the honeybee. And, some important things about the honeybee is that they have some very interesting and intricate behaviors. One of them is called the bee dance, which is basically these bees, when they find a good source of pollen or nectar, they'll go back to their hive and they'll do a little dance. Not unlike students that find some good source of pizza and run back to their lab and tell them about. It's not a joke. They actually do that.
No, we found a great restaurant.
Yes.
We're going to do the restaurant
Exactly,
dance.
and they all do the dance, and then they go to that same way. These bees, once they find that source, they will actually do a dance. And the direction in which they do that dance is the direction of that food source relative to where the sun is. And then the intensity of that dance tells the other bees how far it is. So the other bees will actually watch this bee do the dance, and then they will do that dance with it, and then they follow it and find that food source. So as you can imagine, there's some very intricate and very important social behaviors there with bees. Some other things about bees that are rather interesting is that we've had a long history of domestication, even back to these Egyptian wall drawings here. You can see some of these bees here, and presumably a person with awkward arm that is pouring a bucket of honey. So we've been actually domesticating these bees for a long time. They're very much a part of our human history. We also use them for producing honey, wax, and they also provide pollination services. Now, a lot of people don't often think about this part of honeybees, but it's actually probably one of the most important. They say about, 1/3 of every bite that we take is from honeybees, is from pollinators. And if we look here at this graph, so, pardon me, this here is looking at commodity, from soybeans to tangerines, and this is the percent pollinated by honeybees.
Wow.
So if you look here at this graph, this is almonds. Almonds are 100% pollinated by honeybees.
Wow.
There's about 1.6 million acres of, there's about 800,000 acres of almonds in California. And they're pollinated by about 1.6 million colonies of bees. That's about 85% of the colonies that we have here in the U.S. So as you can imagine, they are very important. Without the honeybees, we would have much fewer almonds. We maybe have some from the natural pollinators, but a large proportion of them come from those honeybee services.
Excellent.
So all of a sudden now in 2006, some beekeepers start describing some symptoms. Abandoned hives. So all of a sudden they start seeing that adults are missing. They see some of the capped brood, so some of those young larvae are still within the beehive. You see some presence of food stores, and the queen bee is still there as well. So it's as if all the workers have just kind of abandoned. And the idea is that they've kind of gone out, they've gotten weak, they've died. They're not necessarily around the hive, they're just kind of gone. And this was coined as colony collapse disorder. And this is one of the reasons for kind of our declining populations of honeybees, but not the only reason. We've also had some others of known causes. So the USDA actually described this as being a serious problem threatening the health of honeybees and the economic stability of commercial beekeeping and pollination operations in the United States. So here we actually have now, this graph shows the number of bee colonies that were lost over every winter. And so the gray bar actually shows, this is self-reported by beekeepers every year, how much they're willing to lose, how much they think is normal. You know, with any type of crop, you know, for anyone who has a little vegetable garden, they know that, you know, those strawberries are getting eaten by those birds. You're going to lose some of them.
Right.
In that same kind of way, these beekeepers, they're going to lose some of their colonies, especially if they're transporting them across the country for different pollination services. They're expecting to lose some due to stress, due to virus, disease, whatever it might be. That's usually around 15%. But ever since around 2006, 2007, they've actually been experiencing over 30% colony loss. That's over the winter.
Oh my goodness. Okay.
Yeah. So as you can imagine, that's about double the number of colonies. And so, you know, when you think about the economic loss, that can be quite drastic, especially to the beekeeper. And then there's also those people that are needing the pollination services as well. So this graph here, you're just loving these graphs, aren't you?
I am.
This
is fascinating.
So starting back in 1987, going all the way to 2015, this is the total number of colonies in the United States, in the thousands. So we can see here that it starts off in 87, you know, at about 3.3 million or so. And from there, it starts to decrease quite drastically. In about 2006, that's when we start seeing what was called colony collapse disorder. Now you'll see it's kind of interesting. We've already had a significant drop in the colonies since that time. You'll see even since then, colonies will, you know, the number of colonies will increase and drop. So beekeepers are able to replace their colonies. So it's not that these honeybees are going extinct, but it's that they are losing all these colonies and they have to replace them. So it comes at a huge economic cost to the beekeeper. The question is now, however, the bigger question, I would argue, and we're not really going to go into this one, is how's this affecting the wild bees and the wild pollinators that beekeeper, you know, there's no one there to replace them.
Right.
You know? There's only now some people that are concerned about monarch butterflies or helping with those populations, but you don't hear about too many people saying, hey, let's raise some carpenter bees and help their populations.
And would you
yes.
say, I'm sorry to interrupt,
That's all right, no.
but would you say that, so on those colonies, the reported graph before, where the beekeepers knew about the decline, do we have numbers on wild colonies that are similar to that, or no?
So we do have the data is much more limited. So because there's a lot of regulations around beekeeping and reporting related to agricultural data, a lot of that is more accessible. In terms of the wild bee populations, you know, there is some data out there in the literature, but not a whole lot.
Okay.
And only now that it's become an increasing concern have there been more publications on that. But it's still kind of a bit of a gap in our knowledge.
Okay.
We'll see here now, right around in the early 1990s, we have the first NEONIC registered. Now, I haven't introduced what a NEONIC is, or even said the word neonicotinoid yet. We'll get to that in a moment, but I want everyone to note that right around the early 1990s is when you get that first neonic registered and being used outside. And you still have some colony loss, but all in all, it's pretty low around this area. Another thing to note is that here in 1987 is when VARROA mice were first recorded in the United States. Now, I know you're, what are VARROA mites?
What is it? Yes.
I shan't not ruin the surprise. It is an invasive mite, so it's a parasite. If you can imagine a parasite the size of a dinner plate on your back.
Okay.
But you're the size of a honeybee. All right. That's basically the size of this mite in relation to the bee. So they are a small mite that latches onto them from when they are brood, when they're little larvae inside the comb of the hive. And they basically weaken that bee, and they can vector a lot of viruses and pathogens of bees that can really knock them out. So just important to note, around that time we get VARROA mites. All right. Now, I also want to say that before we kind of really get into neonics, neonicotinoids, and the impact of pesticides on bees, I would again argue that there are currently, the scientific consensus is that there are a number of different factors that are impacting our honeybee populations. And here in this graph, you'll see things like pathogens. We've had a lot of new bee pathogens that are right now affecting the bees that are, again, being vectored by those VARROA mites. So we have these parasites as well in there. We have acaricides, so these are actually, you could say, pesticides of the mites. So beekeepers are often having to use different types of acaricides in order to manage those mites in those beehives. Well, that can also be a stressor, have an impact on the bees. We also have a reduction in the number of wildflowers and the amount of resources there for honeybees as well. We have a lot of new people getting into beekeeping, that there's beekeeping practice that comes into there. But the one that we're going to focus on is the pesticides. Okay. Is that okay?
That's perfect.
Okay, great.
I was hoping that was the way we were going.
Is this the right talk? Okay.
Yes.
All right. All right, so now all of a sudden we had the situation where anyone who was on the internet in the last year or two, especially on Facebook, would have potentially seen a lot of things about neonics and bees. So this, for example, this is a website where it says ban the use of neonicotinoid pesticides before they devastate bee populations in the USA. As you can see here, about 150,000 people had signed. We have here another one by Some of Us, a very popular online petition signing website as well, that wants to tell Home Depot and Lowe's and other retailers to stop selling neonicotinoid treated plants. About 744,000 signed petitions. And another one, avaz.org, and avaz actually means change in Farsi or in Persian. A little bit of trivia there for you. I know you were wondering, what does avaz mean? And they got 3.5 million signatures to basically get neonicotinoids banned. They want to stop the use of neonicotinoids. And it all kind of spurred off from back in June of 2013. There was a misapplication of a neonicotinoid. So like any insecticide, they are designed to kill insects. And if you apply it directly to an insect that you don't want to kill, oftentimes it will kill it. And so what happened was this person who was a landscaper had applied a neonicotinoid, an insecticide, on a bunch of trees that was actually in bloom and being visited by bumblebees. There was over 50,000 bumblebees dead after the application. The public was become aware of this. A number of articles went out. A lot of people all of a sudden said, oh my goodness, it must be these neonicotinoids that are killing all of our bees. Which isn't false if you're applying it directly to bees or if you're using it, not according to the label. So this was actually considered an illegal spray. According to the label, you're not allowed to do that spray when those flowers are in bloom or when bees are visiting, and any violation of the label is actually a violation of the law. Okay. So now we got these fun little memes where it says, it's no longer a mystery, we know what's killing the bees. They're being poisoned by neonicotinoid insecticides. And so a lot of people, and naturally, when you see something that's potentially causing a lot of harm, you want to rise up in order to cause change. So a lot of people started rallying around this. Now it's gotten to the point where a lot of the nursery growers, and that's who I work with mainly, is the ornamental and nursery producers in East Texas. And they're now having mandatory labeling if they're applying a neonicotinoid that says this plant is protected from problematic aphids, whiteflies, beetles, mealybugs, and other unwanted pests by neonicotinoids. And so if they're selling to Home Depot or Lowe's, they have to have that label. Otherwise, they can't use neonicotinoids. So a lot of growers are actually opting for just not using neonicotinoids so they don't have to bother with the extra labor and the cost of this labeling. And so they're actually reverting to some of the older pesticides, and we'll get to that in a moment. All right, so I've said the word neonicotinoids a whole bunch, all right, and we can actually abbreviate that as NEONICS, okay, and actually they're called NEONICS or neonicotinoids because they're similar to nicotine, in that they are an acetylcholine agonist. Not very important information. Some of the different active ingredients you might find on a pesticide that are within that class of neonicotinoids include clothianidin, metacloprid, thiamethixam, and dinotefuran. Those are some of the various. So if you're in a Home Depot or Lowe's, you're looking at insecticides, and you see one of those under the active ingredients, that belongs to the neonicotinoid class. So some of the products that people might see include Merit, Marathon, Premise, Advantage, Safari, Transect, Xylem, so on and so forth. These are mostly items that are actually registered for pesticide applicators. And there's a number of different products that's for the homeowner. So the idea is that it's a relatively new chemistry. So like I said, it first really came into the market, it really started being applied in the early 1990s. Yeah. And the idea is with these newer chemistries, you're trying to get less toxicity to non-target organisms. Okay. So like your deer or your avian species or your fish. That's your neonicotinoids have very low toxicity towards those other higher order organisms and have higher toxicity towards insects. And now it's gotten to the point where neonicotinoids are considered so effective that about 33% of our U.S. Soybean acreage is planted with neonics, like already coating the seed.
Okay.
And the reason for that, we'll get into in a moment. Here's our nice little biology lesson. Acetylcholine is a type of neurotransmitter, and acetylcholine receptors can take that acetylcholine. So it's related to, you could say, your nervous system. And so what neonicotinoids do is they bind onto that receptor and they don't let go. So other things can't bind onto it. And that's how it basically works. And that receptor is actually the target for about 24% of the insecticides back in 2007. So it's a very popular site. So one of the advantages of neonics is that they can be taken up systemically. So you apply to the pot of your plant. So here are these amazing red dots. And this animation took me hours to do.
Lots of graphic design.
Absolutely. There we go. Look at that. So once you apply it in there, it actually gets taken up by the plant with the nutrients. It's water soluble, goes up into the leaves, so that any insect feeding on those leaves take it up and they become happy. No, they die.
You had me going there.
Yeah, right? You're like, happy?
Yeah.
And so we also have these beneficial insects. And the nice thing is that they don't feed on the leaf material, right? So they're not going to be fall victim to the effects of neonicotinoids unless all of a sudden they start eating the leaves. And so neonicotinoids, or neonics, can be considered relatively targeted in the way that they work because they're taken into the plant and only things actually feeding on the plant, which is almost how we define a pest, is going to be affected by that. So here we have a praying mantis. Here's a green lacewing larva. If you have any spare time, YouTube green lacewing larva mauling at aphid. I don't know if actually you'd find one if you put in mauling, but they're amazing. They have kind of two fangs and they're hollow, and they pierce the aphid and they inject digestive juices inside. I'm giving you nightmares, aren't I?
No.
Okay, all right. And then they suck them up.
I'm going to YouTube this.
Yeah, excellent, good. All right, so another part of the advantage of neonicotinoids is you don't need to apply nearly as much as some of the older chemistries to get the effect. So here, this graph is showing the amount, the gallons of active ingredient you need per hectare in order to get your kill, essentially, of your insect. So, lindane as a spray, let's say, is about 1,350. Carbofuran is 600. Fipronil is 250. When you get to these two neonicotinoids, which is imidacloprid and clethianidin, you're looking at 100 or 40.
Much less.
Much less. So you're getting actually much less applied out in the environment. So that's considered an advantage. Now, we're going to get into the current research, and this part gets a little bit in depth. So at this point, you can go down to the settings in the bottom right of the YouTube video, click on speed, and click the 2, so it goes doubly as fast, because I know you're that good. So there's a lot of research on this, and it's really hard to answer the question, are neonics killing the bees? Because it's yes if you're applying directly, but it's no if you're using in a different way, using responsibly. So we're going to just look at some of the data here. So this is a research project done in Sweden. They looked at beehives and different bee colonies. They looked at wild bee populations as well, either near farms that had treated seeds. So these are neonicotinoids treated on the seed and was taken up with the seed. Or near fields that did not have neonic treated seeds. And tried to look for differences to see if there's any impact of being near those different types of farms. So you'll see here, this is the south part of Sweden, and there's the ones, the black, I think the dark ones are the ones that were treated, and the non-treated. And we can see that when they were near a field that had seeds that were neonic treated, you all of a sudden had reduced wild bee density populations. You had reduced solitary bee nesting, reduced bumblebee colony growth, and reduced reproduction of bumblebees. So you had some negative impacts on some of those wild pollinators. But he actually had no significant impact on honeybee health. So this is kind of interesting where you go, okay, well, so honeybees aren't the only thing that matter, and they're not the perfect indicator of what's happening to other pollinators. Because in this situation, we can see nothing's happening to the honeybees, but all these other wild bee populations are having a negative impact. Absolutely. You can also see, so a lot of people made the argument that these seeds, so they're, you can imagine a very tiny seed, and they put this neonic lace almost like in a clay kind of particle with that seed. And they use these like seeders to plant them in the ground. People were arguing for a while that those particles, that clay, is really tight on that seed, and it's not going to escape or go anywhere else. That it goes into the ground with the seed. Well, this scientific paper here actually demonstrated, with certainty that in this situation with these types of seeds and the type of seeder that they used, now there's different types of seeders and different seeds, so it's different situations, but in this case the neonic did actually get off the seed and go on bees. So this is actually a very close picture of some bees, and you can see here that chunk right there, that's a bit of that clay. That's actually a particulate off that seed that's gone on that bee. So you actually can get, in some cases, again not all cases, you can get those neonicotinoids coming off those seeds. And you can even get a significant amount. So this chart will probably put you to sleep, but there is some important information. If you just look here at the far right, this is the quantity of insecticide in nanograms per bee. So that's 10 to the negative 9. So that's 0.000000000. So it's very little, but it's also always dosage makes the poison, right? So there's, if you can have a lot of water and you're not going to die, right? You have some cyanide, you're going to die. If you have a certain amount of salt, you have too much salt, that can also kill you. So there's always depends on what the chemical is. The dosage of it makes the poison. So just this data alone doesn't tell us a whole lot. It just tells us that the bees can get neonicotinoids on them if they're close to these seeders. And if you actually then take those bees, so you have the seeding machine, it's like putting seeds in the ground, you have a bee colony right next to it, and you catch these bees that are next to that cedar, and you then take them into a hive. So now we're looking at survival. Now, do these bees survive? They have some of that neonicotinoid on them.
Right.
We're feeding them some sugary solution to keep persisting. We can see here, now the hollow graph is low humidity, and the solid graph is high humidity. And this is the number of dead bees. So the higher that bar is, the more dead bees you have. So you can see in high humidity, just after 15 minutes, and this is looking at minutes after sowing or after collecting those bees, pretty much all of them die if they're in high humidity. So this is imidacloprid and clethoanidin. This is two different neonics, and you get a very similar effect. But you can see if they're in low humidity, they don't really die. So it's kind of an interesting effect where there's multiple factors, so if there's multiple stressors, then it can kill the bees, and in this case, the neonic is one of those stressors.
Okay.
And we also have this other instance where people were saying that, well, we don't think that these neonics actually make it to the flowers quite often because, when you're trying, neonics often don't work very well against flower pests. And so it was thought because those neonics don't actually make it there. And then there's quite a bit of data just coming out now because there's not a whole lot known about whether the neonic, when you apply it into the soil, does it make it into the nectar and pollen? And that's where the bees are feeding.
Right.
And so what this study here looked at was pumpkin flower pollen. And you can see here this is different types of treatments. So either it's in a bedding plant, it's already in a bed, and you're doing a soil drench. Versus a transplant drip. So it's still in a little pot, right? Is what you would kind of get at Home Depot and then plant in your own garden, your vegetable garden at home. And if it's under some type of a drip irrigation with neonic in there, that's when you get the highest amount of neonic in there. So this is imidacloprid. Okay. You get about 80.2 nanograms per gram of solution. Now, so what does that mean? Well, so Apis mellifera, which is the honeybee, eats about 0.013 grams of pollen per day. I sat there and I counted. No, I didn't actually do that. And so a bee eats, and that means that if a bee were to feed from this pollen, from let's say the highest, the highest potential amount that it might get, it's eating this much imidacloprid per day. The lethal dosage, the amount that would actually kill that bee, or actually, I should say more accurately, would kill 50% of a population of bees if they all fed on it, is this amount. And you can see it's about 3-fold more. So that means that, the amount that the bee would get from this transplant drip is actually pretty high. Imagine you were having 1/3 the amount of cyanide that would normally kill someone. That's probably
scary.
Yeah, probably ill-advised, if
Yes.
anything. Yeah. However, that's not the full story. The product that they use is called Admire Pro Systemic Protectant. And you'll see right on there, on the label, right now, it says that you cannot apply when the plant is in bloom or when it is attractive to bees. And so you have, this case where, again, so if you were to do a misapplication, if you were to apply when it is in bloom or when bees are present, then it's going to have a very negative impact on the bees. If you wait or apply something different that doesn't have this type of warning on the label, then you're going to be okay.
So it's all about using the product correctly as
Absolutely.
labeled.
Absolutely. That's, I would argue, at least is a big part of it.
Okay.
Now, with a lot of these studies, a lot of them have their limitations, and a lot of them have very interesting things to say as well. So, there are some things where, we use them according to label, like some of those cedars, and they can have some negative impacts, and so regulation is just starting to catch up now in order to change some of those things.
Okay.
The same way, this bee box is actually new within the last year or two. It was always under the environmental hazard section of a pesticide label, and it was kind of laced in there in the text, and people didn't really pay close attention to it. And so just more recently now, they've made it very obvious with this big bee advisory box, a picture of a bee, so people know what it is, and,
Yes.
And have made it really obvious. So there was another study done with what's called a Y-tube olfactometer. That's a fancy scientific way of saying it's a fork in the road, and you get to choose which way to go. So they basically give this bee either just honey or this honey and the neonic coming down this tube. And so the bee will travel up this tube. This also took me forever to produce. Look at that. Just incredible skills. And at this point, that bee can decide whether to go left or right. And this is an idea of preference. Does that bee have a preference for which one? So people were arguing that, okay, well, look, these bees, if the neonics are bad for them, they're smart enough.
They
they're
won't
gonna...
choose that.
Absolutely. Exactly. It turns out, similar to people smoking, we don't always choose what's best for us. So here, anytime this bar is above this graph, that means they're preferring the neonics. Anytime it's below, that means they're preferring against the neonics. And here are the different types of neonics: imidacloprid, thiamethoxam, or clothianidin. But that's not even that important, because if you can see here, most of them are above. And so regardless of the concentration, this is looking at different concentrations. This is our bumblebee, and this is our honeybee. So you can see our honeybee actually prefers, and this is a study published in Nature, it actually prefers the neonics. So they are like, give me that nicotine. Yeah. All right. And then we have some other very interesting things. So the challenge is now, we're getting to the point of asking ourselves, how do we actually test the potential off-target impacts of insecticides? Because it can impact different organisms in so many different ways that it can be kind of challenging trying to find an economic way to test those different ways that it might impact those different insects. So here we have it actually impact the immunocompetence of honeybees. So here we can just see, ignore these bars here for a moment. This is just control, so that means they weren't treated with anything. This is a healthy bee. If you stick a needle, this is a plastic needle, just put right into a bee, those particles of its immune system will bind onto it, and they actually are pigmented. So you can actually see that, there's a lot of good, healthy immune cells going on there. When you apply different rates of these neonics, all of a sudden that melanization decreases drastically.
Yes.
So, again, looking at multiple potential factors where you have neonics, you have a number of new diseases that are coming in, the VARROA MITE. All these things may be combining to really take a big toll on those bee populations. All right, so now we've just seen some things that makes it seem, okay, neonics are horrible, right? They are hurting the bees, their immunocompetence, their preference, all these kinds of things, but it's never quite that simple. So the thing is, like I mentioned, some of the growers are going to some of the older alternatives. So if we look just as an example, here, this chart is looking at different classes of insecticides. So we got imidacloprid, malathion, acephate, and carbaryl. That's carbamates, organophosphates. We have our, what was that one? I just skipped my mind. And we have imidacloprid. It'll come back to me in a moment. So we have here now the amount. So this is the amount of active ingredient per 100 gallons of formulated product. So you can see here, for example, if you're applying imidacloprid, 10.7 milliliters of that is going to be imidacloprid. Malathion is about 370, acephate is about 220, carbaryl is about 407. Now, in that 10.7 mils, these numbers here tell you how many of that particular type of organism it can kill. So rats, it's going to kill much less than 1. All right, birds, again, much less than 1. Fish, barely going to kill any fish. Look at bees. Woo, that's 3,340,000 approximately bees that it can kill. So it is highly toxic to bees. Now, if we look at malathion, on the other hand, we'll see that its toxicity to bees is about 1/3 of that of NEONICS. But if you look at fish, it has a huge impact on fish.
Right.
If we look at acephate, we have a similar thing where also has high toxicity to fish, also has relatively high toxicity to birds. And carbaryl has the highest amongst all of these classes for rat toxicity. So we see that some of these older chemistries, although they might have less of an impact on bees, are having a much higher impact on some of these other higher order non-target organisms. We have this other interesting situation here where these beekeepers in Ontario, all of a sudden they had this one loss over one summer, huge colony losses. So about 240 bee yards were impacted with about 4,500 to 5,800 affected hives, same as Quebec in Canada. And we had the situation where they're right next to either corn or soy, and they found that it was because of those neonic treated seeds. And they were actually directly impacting their hives and causing some great undue harm. Oh my goodness, well that's very simple and straightforward. But then on the west side of Canada, we have the situation where the Canola Council of Canada says that bees are not affected by treated canola seed. Well, yeah, of course the Canola Council would say this, right? I mean, it's in their benefit. So I called actually some of the bee regulatory officials in Western Canada, and they said, no, it's actually true that the beekeepers in the west side of Canada have a very good relationship with these canola growers. And because they're actually treating the seed with the neonic rather than doing sprays afterwards, when they treat the seed, it protects it for the first 3, 4 to 5 weeks of that crop. So you don't have to do any sprays during that very initial time. And that also means that you won't have sprays that are potentially hitting the bees. And so they have a very good relationship, to the point that even the Ontario beekeepers are like suing the growers, and then you have the Alberta beekeepers opposing the Ontario beekeepers lawsuit. So they're actually defending the growers in Ontario, the beekeepers in Alberta are. So you got this very interesting kind of thing happening there. We also have this interesting case where in Australia there is no sign of colony collapse disorder. So very few submitted reports of adverse effects of pesticides on bees and other pollinators in Australia. And again, if we look at this very interesting graph here, so in Australia, they actually don't have the VARROA mite either. And so they are missing, let's say, one of the potential stressors. They use Neonicotinoids there. They have those, but they do not have the VARROA mite. And so again, to look at kind of the broader picture, we have here the VARROA mite being introduced, and that's when we really start seeing these numbers of colonies decreasing. Again, not to say that neonics are not having an impact. Certainly in certain situations they are, but I am not convinced that they are the main factor.
Right.
And when you look at really the big picture and the role of neonics in agricultural usage and how it reduces the amount of pesticides we use, then it's actually, by, let's say, banning or restricting neonics, you're potentially reverting back to some of those older chemistries and more insecticide use. We also have, again, talking about the VARROA mite, there was a recent study here that looks at the number of VARROA mites, number of VARROA mites per 100 bees within a number, they looked at hundreds if not thousands of colonies over the different months. So here, September, October, November, so this threshold is at about 2.6 VARROA mites per 100 bees is the acceptable level. And they were finding that on average, the number of VARROA mites is actually higher than that acceptable level in those months. And so, again, it shows that those VARROA mites are actually a little bit more of a problem than perhaps we have given attention to. In this graph as well, so we see here the deformed wing virus. That's a virus of bees. And that is all of the dark bars represent colonies that have that deformed wing virus. And we can see that this is the number of varroa mites per 100 bees, either if there is deformed wing virus or isn't. And you'll see that anytime that there is deformed wing virus, oftentimes the varroa mites, the number of varroa mites is also much higher.
Okay.
So whether it's because having that virus means that they are unable to fight off the mite, or those high loads of mites is actually what's causing that virus. It's a correlation, not a causation. So we don't know which one's which. All right. So now the question is, what can you and I do? At the end of the day, we want to know what can we do. So first things first, you can use a NEONIC decision tree, at least what I call it. There's a little decision tree that I made. You can go, throw in a little shameless plug, sixleggedaggie.com. Am I allowed to do that?
Yes.
All right, good.
We can run that on the bottom or something.
Okay,
sure.
Great. Yeah, just put it right here, just right now. And good. And if you go there, you'll see, I think it's the second most recent post on there. I have a little decision tree that you kind of use to decide, are your flowers in bloom? If yes, can you apply that neonic in a way that would not actually go onto the flowers? Again, if yes, so if you're going to apply as a soil drench, if yes, then you got to recognize there isn't a whole lot of data out there to show whether it's going to show up in the pollen or in the nectar of all the different plants that we have, and always make sure you follow the label. So if the label says do not apply when in bloom, don't apply it. Otherwise, if you're still unsure, you can use this tree to kind of help guide you. There's other things like, for example, can this plant be in bloom within the next 2 to 3 months? If it's a large tree, sometimes it can end up in there afterwards. So that's something as well. Again, we don't have a whole lot of data, so it's just things to consider for the common homeowner. We also have another thing where you want to look at the application timing. So even if you are applying something that's not a neonicotinoid, even some of your organic sprays can have impacts on bees. So if you know your bees are often visiting your flowers, you want to apply it sometimes when those bees are not out there. So in Sao Paulo, Brazil, because apparently that's one of the few places that have actually done this study, you'll see that the number of bee visits varies throughout the day. So they'll be there early in the morning, and you can just go out there and watch your garden and have an idea of when are those bees really out there. They'll be there in the early morning, then leave in the afternoon, and evening they're back in their hives. They're not outdoors anymore. They're inside watching their TVs or whatever. At that point is maybe when you want to apply your pesticide so that you're not hurting your bees. Another thing to consider is wildflower gardens. And I'm not specifically endorsing this website, but this is just where I got this wildflower mix from, because it all depends on where you are. There's many different wildflower mixes that you can look up, and there'd be things that are native to, let's say, wherever you are in Texas, and will provide flowering throughout the entire season that the bees would be foraging. So in this way, when they are just coming out of winter and they need some food resources, there'll be some flowers there. When it's late in the season, they're trying to really gather up for winter, there'll also be some resources there. So by just, having a beautiful garden, you can help those bees. I know it sounds like a crazy idea. But,
right. Who would want pretty flowers?
Who would want that? I don't know. All right, another thing you can do then is actually if you get a garden like this, you can help with the Million Pollinator Garden Challenge. So there's this challenge, and you can go online and, you just have to Google, oh no wait, I have the link right here. I was wondering where that was. millionpollinatorgardens.org. And you can register your garden and become a part of this huge initiative in the U.S. where people are trying to help pollinator populations.
Excellent.
And that is all.
Fantastic. Well, I think that this has been extremely beneficial for myself, and I hope all of our viewers. Certainly, it sounds like it's not as simple and as easy as one answer, like most things.
Absolutely.
There's a lot that people need to know. So we will link your contact information.
Thank you.
In case there are questions. And then what was that website again?
Which one? My website, sixleggedaggie.com.
Excellent. So we'll make sure that people are able to get in touch with you and they can get answers to their questions.
Absolutely,
and as always, we appreciate our Next Talk viewers. And remember, this was a viewer or presenter request. And so if you have more, we'd love to hear them at next@ag.tamu.edu.